Good morning, my dear friends. I hope you all are doing great. Today we'll be talking about the biomolecules. We have accomplished the theory part of biomolecules, and now we will be discussing about the competitive part of this particular chapter, biomolecules. So my dear friends, you have to make your concepts very much clear. Okay, if your concepts are clear, then you can easily attend the questions in competitive exams. So let us take on the questions from all the three competitive exams here, from CET, NEET and JEE. So I will bring in all the questions from these three competitive exams and let's do it. So let's get started with the question number 1. Which one among the following is an essential amino acid? You can also say amino acid. So if this is my question, okay, let me give options for you people. So first amino acid I am writing histidine, then it is cysteine, glycine and glutamic acid. My dear friends, when we were dealing with the theory regarding the biomolecule chapter, I told you have to remember one mnemonic. And what was that mnemonic by which you can do this question in a flash, in a very less time? Have a look. I told you should remember this mnemonic: private, time, hal. So this mnemonic you have to remember: private, time, hal. Okay. What is this private, time, hal? These all are basically essential amino acids. Okay, this P stands for phenylalanine, V stands for valine, T stands for thymine, and this T stands for tryptophan. I stands for isoleucine, M stands for methionine. Then you have H. H stands for histidine. A stands for arginine. L stands for lysine. And the last L stands for leucine. So my dear friends, these are all your essential amino acids. So they are your essential amino acids. And how many are these? We know that they are 10 in number. So I will write down we have 10 essential amino acids. If you remember this private, time, hal, it's basically a mnemonic. Okay? You can easily memorize these 10 amino acids. When you know that this private, time, hal, you can remember these 10 amino acids easily. These are all essential, okay? And the rest of the 10 will be non-essential amino acid. Have a look, what is my question? Which one among the following is an essential amino acid? Look here. We have histidine, cysteine, glycine and glutamic acid. If you look at histidine, you know in hal, look here. H stands for histidine, and histidine is basically essential amino acid. Histidine. Have a look. So that means the answer is histidine here. It is my essential amino acid. So this is essential amino acid. So very easy it is. Now if you talk about cysteine, cysteine is not here. You can look, you can cross check. Cysteine is nowhere. Glycine is nowhere. And even glutamic acid is nowhere. You should cross-check all the amino acids. And once I cross-checked, I found that only histidine is essential amino acid. And rest of the three are non-essential. So these are non-essential amino acid. So I am done with the question. So see here, my dear friends, I have given this much of theory here. It's not required. You have to remember only private time hall. And you know that. Then you should start seeing these amino acids here. Then you have to, calculate in your mind only, or you have to just recall in your mind only that histidine is basically, coming in the Hall region here, H. So it's essential and rest are basically non-essential, but you should cross-check. Because sometimes, you can have more than one option as an answer, okay? So my dear friends, this is the answer. That is histidine, okay? So dear friends, let's look at the question number 2. Which of the following contains cobalt? So metal cobalt in its structure. So let me write down options for you. So the first option I am writing here as chlorophyll. Second option I am writing it as hemoglobin. Third option I am writing it as cyanocobalamine, cobalamine. Then you have all of these. So tell me, which one among the following does contain, cobalt in its structure? Okay, if you look at them, see here, it's very easy thing. If you look here at this particular terminology, there's a term called as cobalt. It's related to, cobalt. So you can easily answer it that option C is the answer right out here. Because in cyanocobalamine there is cobalt, C-O-B-L, cobalt. So it will give you some hint that, it contains cobalt. Okay, my dear friends. Now let's look. Chlorophyll molecule is basically a green pigment, okay, in plants, and it is very much helpful, in photosynthesis process, okay. I am not going in detail actually, but I will tell you that chlorophyll contains basically magnesium element. Hemoglobin is associated with RBCs, I have discussed about it. It contains iron. And cyanocobalamine is also known as vitamin B12, and it contains cobalt. It contains cobalt. So this cannot be the answer because only one option is containing the cobalt. So the answer is C, cyanocobalamine. It contains cobalt. Okay, so answer is the third option. Please make note of this. Question number 3. Which one among the following will give positive tolerance test? Glucose, fructose, acetic acid or formic acid? You just have to tell me. But before that, you need to remember this thing. Have a look here. I have already discussed this thing with you people. Substances containing following groups can give Tollens test. Okay, what is that? What are those groups? Let's talk about those groups. The groups are, a substance should have an aldehyde group, correct? A substance should have alpha hydroxyketone or alpha hydroxyketonic group. Okay, so if any substance has aldehyde group or alpha hydroxyketonic group, or it may have a hemiacetyl carbon, or it may have a hemiketyl carbon. So if any substance contains these groups, that substance will definitely give us Tollens test. Tollens test is also known as, you can remember, silver mirror test, my dear friends. Correct? So, but I should talk about that substance which does not give Tollens test. Look here, substance containing following groups can give Tollens test. That means any substance which contains any of these groups can give Tollens test. Correct? But have a look here. I have to find out that substance which will not give Tollens test or silver mirror test. So let's find out. Have a look. If we talk about glucose molecule here, everybody knows about the structure of glucose. Glucose molecule will have an aldehyde group, correct? So I will mention it like this: CH2OH, okay, or CHOH, sorry. Then I will write it 4 times and CH2OH. This is our glucose molecule. And you know that it has an aldehyde group. It has an aldehyde group. Okay. So it will give Tollens test. This glucose will give Tollens test. So this is not our answer. Now second point is fructose. Have a look at fructose. If you look at the fructose, you will find out you will have CH2OH, then you have C double bond O, then you have CHOH we can say, or we can say OH here and H here. Let's draw the complete structure because it takes time here. Okay, we have here OH, H, okay. Now look here, my dear friends, 1, 2, 3, 4, 5, 6. This is basically our fructose molecule. And you know this is a functional group called as ketone, correct? And this is the carbon near to the ketone. Carbon adjacent to the ketone is known as alpha carbon. So on alpha carbon I have OH group, so it will become alpha hydroxy ketone. So this part will become alpha hydroxy, and CO group is known as ketone. That means your fructose molecule does have alpha hydroxy ketone. Okay, so it will give positive Tollens test, or it will give Tollens test. This will give Tollens test. Will give Tollens test. This guy will also will give Tollens test. Okay. Now let's talk about now acetic acid. Okay. If you look at acetic acid, you will find out CH3C double bond O and OH. This guy is your acetic acid. Correct? Acetic acid has basically a carboxylic group. This is carboxylic group. So in acetic acid you have carboxylic group. It does not have aldehyde. It does not have alpha hydroxy ketone. It does not have hemiacetal carbon or hemiketal carbon. It's a carboxylic group. So will not give Tollens test. So our answer is basically now acetic acid, because it does not contain aldehyde, it does not contain alpha hydroxy ketone, so will not give Tollens test. Let's talk about now the last one here, formic acid. If you look at the formic acid here, have a look, the last one. Okay, and even I can draw the formic acid here also. Have a look. C double bond O, H, OH. Can you zoom here, sir? Okay. Now look here. Okay. If you look on this side, have a look. If you look on this side of formic acid, okay, you have a formic acid here. This part becomes aldehyde. CHO, aldehyde. If you look on this side of formic acid, this becomes carboxylic group. So formic acid is basically having both the groups, CHO aldehyde and COOH as what? Carboxylic group. So it has both aldehyde group as well as carboxylic carboxylic group. So when it has aldehyde group, we need aldehyde group here. So CHO is aldehyde, COOH is carboxylic acid. Carboxylic acid will not give the Tollens test, but this formic acid also contains CHO. CHO stands for aldehyde group, correct? So it has aldehyde group also. So I will write down, will give Tollens test. Or we can say will answer Tollens test. We can say, I am writing here will give Tollens test. You can also write down will answer Tollens test. Means it will reduce the Tollens reagent. Okay. Which part of Tollens reagent? Cellular, from +1 to 0. That I am going to discuss in other questions. But here we have to only tell that whether it will interact with the Tollens reagent or not. Correct? So I have just given you the idea about the formic acid here. Formic acid contains CHO. Can you zoom it here, sir? Zoom it on this particular structure, formic acid. Okay. Now look here. Formic acid is HCOOH is formic acid. It contains CHO one side, CHO, that is aldehyde group. Other side, if you see COOH, it becomes carboxylic group. Carboxylic group will not give Tollens test, but CHO will give, that's aldehyde. So overall, it will give Tollens test because it contains CHO, aldehyde group. So my dear friends, only acid which is not giving the Tollens test here is here acetic acid. Formic acid will give Tollens test because it contains aldehyde group. I hope you have understood, my dear friends. Okay. So acetic acid does not have any aldehyde group. It has carboxylic group. Once again, I am telling you, if you look at acetic acid, this is our acetic acid. I can call it as acetic acid. It has only COOH, carboxylic group. So it will not give Tollens test. But if you look at formic acid, CHO, aldehyde one side, COOH, carboxylic group other side. But aldehyde is there because we need aldehyde. So aldehyde is there. So it will give the Tollens test. So answer will be acetic acid. It will not answer the Tollens test. So dear friends, look here, question number 4. Which one among the following is optically inactive? I told you last time that if any molecule has a chiral carbon, it will be optically active. If it does not have a chiral carbon, it will be optically inactive. And when we have dealt with the glucose molecule, we already know that the glucose is basically having 4 chiral carbons. If you open up the structure of glucose, because I have already discussed, the glucose has 4 chiral carbons. So when it has a 4 chiral carbons, and we have also seen experimentally that it can rotate the light in clockwise direction. And we know that it is dextro-rotatory. Okay. It shows optical activity, means it can rotate the light in clockwise direction. So it is dextro, or we can say dextro-rotatory molecule. Okay. So it's optically active. Optically active. If you talk about now fructose, fructose has only 3 chiral carbons. If you prepare the solution of glucose, okay, we have already discussed this thing earlier on in theory. It can rotate the light in anti-clockwise direction, so it's levorotatory molecule, and so it's optically active. It can rotate the light. If you look at the glycine, I told you that out of 20 amino acids, if you remember, I have already discussed this thing. Out of 20 amino acids, okay, only glycine is optically inactive. Optically inactive. Why? Because it does not have chiral center, or you can say it does not have a chiral carbon. Glycine does not have a chiral carbon, so it's optically inactive. So this guy, okay, is optically inactive. it has no chiral carbon. Okay. So my dear friends, glycine has no chiral carbon, so it is optically inactive. Okay. Remember, out of 20 amino acids, only glycine is optically inactive. So rest of the amino acids are optically active. So only this guy is optically inactive. Only glycine. If you look at the structure of glycine also, the basic structure is like this of glycine, and the R group which is here is also hydrogen. So the side chain is also hydrogen. So this carbon is attached to, can we say that this carbon is attached to 4 different groups? No. If this is A, let us suppose, if this is B, this is again A, and this is, let us suppose, C. So it does not have, this carbon does not have 4 different groups. 2 groups are basically similar here. So if it does not have 4 different groups around it, so it is not a chiral carbon. So I can call this carbon as achiral. And if this is achiral carbon, and achiral carbon is basically optically inactive. Okay, so molecule will become optically inactive. This is our glycine. Then rest of the 19 amino acids are optically active. Look at, so we have to talk about which one among the following is optically inactive. So our answer is glycine is optically inactive. And I told you that the rest of the 19 amino acids are optically active. So cysteine is an amino acid, it will be optically active. Because only glycine is optically inactive. Okay, so cysteine is optically active. Have a look. If we draw the structure of cysteine molecule, it will be like this: H, COH, NH2, then CH2, SH. This is the R group, okay? CH2SH. Correct? Now this carbon will be chiral carbon. You can see it. This is A, this will be B, this will be C, and this will be D. This carbon is surrounded by 4 different groups. So obviously this carbon is now chiral carbon. So when any molecule has a chiral carbon, it will be optically active. So it's optically active. So inactive is only glycine. Please remember that. Please make note of this. Dear friends, which of the following amino acid contains sulfur? So we have already discussed about the 20 different amino acids. So you must be knowing that which 2 amino acids are there, because I am telling you that there are 2 amino acids out of 20 which contain sulfur. Okay? If you remember the names of those 2 amino acids, you can easily do this particular question. Okay? Everybody knows about one. Most of the people will be aware about that one, that is cysteine. Everybody is aware? Because in insulin we have discussed about disulfide bonds through cysteine. So this will be actually in your mind. But you know that there is one more, that is methionine. Methionine also contains sulfur. So my dear friends, methionine and cysteine, these are the 2 amino acids, they contain sulfur. Please remember that. So the answer will be both A and B will be the answer. So D option is the answer. So let us draw the structure of methionine. This is the basic structure everybody knows: carboxyl group, hydrogen, and amine group, or amino group we can say. And the R group in methionine is basically CH2, CH2, S, CH3. This is the R group. Now it contains sulfur. Correct? So this is our methionine. So my dear friends, I am just telling you that how they contain sulfur. You can directly write down your answer and you are done. If you have already properly read the concept, okay, if you have visualized the structures properly, if you have seen the structures properly, you can just do this question in just 1 or 2 seconds only. Okay? But if you look at the structures, let me show you the structure so that it will be confirmed that they contain sulfur. Okay? Cysteine. Basic structure is this. Okay, NH2, and this is the basic part. The R group in cysteine will be CH2SH. Look here, it contains sulfur. This is R group, side chain. So this is our cysteine amino acid. Now if you talk about serine amino acid, it will be like this: H, COOH and NH2, then CH2OH. This is the side chain R group, and that is serine amino acid. So this does not contain sulfur, it contains alcoholic group. So your two amino acids, please and please remember, the two amino acids are there which contain sulfur. One is methionine and one is cysteine. So the answer is D option. Please remember that. Dear friends, question number 6. How many peptide bonds are present in decapeptide? Decapeptide, it means 10 amino acids. Okay? So decapeptide means 10 amino acids. So my dear friends, if one peptide bond is formed between two amino acids, correct? Then how many peptide bonds will be formed between 3 amino acids? 2. Between 4, 3. Between 10, it will be just 9. That means if you have 1000 amino acids with you, the number of peptide bonds will be 1000 minus 1. Okay, what is that? 999 peptide bonds will be there. Have a look. So decapeptide basically means 10 amino acids. So remember, N stands for here number of amino acids, and we know that how many amino acids we have? 10. Then I have to find out peptide bonds, correct? So number of peptide bonds, number of peptide bonds are equal to N minus 1. We know that N value is how much? 10. Number of amino acids are 10. So minus 1, how much is that? 9. So we will have 9 peptide bonds in a decapeptide. So 10 stands for here decapeptide. 10 amino acids decapeptide. 8 amino acids octapeptide. Correct? 2 amino acids together, that's called a dipeptide. 3 tripeptide. So my dear friends, how many peptide bonds are present in decapeptide? Obviously N minus 1. How much is that? 9. So the answer is 9 here. So if I give you now this explanation for this, have a look. My dear friends, if I have an amino acid with me, have a look. Let's call R1. Then we have here NH2 group. Let me open up this thing, C double bond OH. Then we have CH, okay, R2, then COOH, carboxyl. Loss of water will be here, correct? Due to that loss of water, a peptide bond will be formed between 2 amino acids. So this bond is our peptide bond. This is our peptide bond. We have already discussed about it, okay? Now between 2 amino acids, how many peptide bonds are there? 1. So what is the N value here? Here the N value is how many amino acids we have? 2 amino acids. So N value is 2. Then number of peptide bonds are N minus 1. That is 2 minus 1. How much is that? 1. So peptide bonds are 1 and number of amino acids are 2. Correct? So my dear friends, I hope you have understood. If you have 10 amino acids, peptide bonds will be 9 only. 1000 amino acids, peptide bonds will be 999. Please remember that. And remember that CONH bond is nothing but it's a peptide bond. Dear friends, which one out of the following is basic amino acid? Correct? Let us see here. My dear friends, if I talk about any amino acid, if it is to be acidic, let's suppose if any amino acid is to be acidic, for acidic amino acid, what we require? Basic group or groups should be less than acidic groups in it. So in acidic amino acid, if you look, what happens? Basic groups are less than acidic groups. Who is your basic group? NH2 group is basic group. And who is acidic group? Carboxylic group is acidic group. So NH2 group will be less than COH groups, correct? Now if you have now basic amino acids, in basic amino acid, what happens? Obviously basic group will be greater. Basic groups will be greater than acidic groups. Basic group is your NH2 and acidic group is COOH. Can you focus it here, sir? Okay. Now you can have a neutral amino acid as well, or amphoteric amino acid we call it as neutral amino acid. Here in neutral amino acid, what happens? The basic groups will be equal to acidic groups, which means NH2 group will be equal to COOH. Is it visible? Okay. Now my dear friends, let's have a look here. This is the basic structure, then this is the side chain. This is common in every amino acid, this part is common, this part is common. I am looking for the basic amino acid. So for basic amino acid, basic groups should be more than acidic groups. What is your basic group? NH2 group should be more than COH groups. That means amino groups should be more than carboxylic groups. Have a look. One amino group, one carboxylic group. Carboxylic group is 1, amino group is 1, so it is neutral. So first one is neutral amino acid. Amino acid. Now look here, second one. Carboxylic groups are how many? So you have one carboxylic group here and two carboxylic groups here. And amino group is only 1. Yes? So in this case, carboxylic groups are more than basic groups. So acidic group, this is also acidic. And this guy is basic. So two acidic groups, one basic group. That means acidic groups are more than basic groups. So it will be your acidic amino acid. Acidic amino acid. Now look here, basic group and acidic group. Here we have one basic group and one acidic group. So this is basic and this guy is acidic group. This one is basic, this one is also basic. So this is basic group, this one is also basic group, and this guy is acidic. Now in this case, we have two basic groups. Basic groups are more than acidic group. Acidic group is only 1, basic groups are 2, NH2 and NH2. That means this guy will be your basic amino acid. This will be your basic amino acid. Now look here, acidic group, this guy is also acidic, and basic group is only 1. That means acidic groups are more than basic group. That means it is your acidic amino acid. Acidic amino acid. So my dear friends, if you look at the first one, you have hydrogen. Okay, side chain is only hydrogen, which means actually it's a glycine amino acid. So this guy is your glycine. So glycine is your neutral amino acid. Okay, you need not to tell which amino acid is this, but I am giving you some extra information here. Otherwise you can easily recognize these things by their number of groups. If acidic groups are more, acidic amino acid. If basic groups are more, basic amino acid. If acidic group is equal to basic group, then neutral amino acid. That's it. But if you look at this one, B option, it's your acidic amino acid. If you look at a side chain, it's CH2 2 times and COH. This is basically your glutamic acid. If you look here, this is your basic amino acid and the side chain is CH2 4 times and NH2. CH2 4 times and NH2 is nothing but it is lysine. So lysine is your basic amino acid. If you look here, CH2COH, it is basically your acidic amino acid and it is your aspartic acid. Aspartic acid. So your answer is which option? Your answer is basically the C option, because you have to find out the basic amino acid. See here, you need not to write down this much of explanation, you need not to give. In competitive exams, you have to just recognize which group is there. Why I am giving you this much of information? So that by this information you can solve other questions as well. Okay? So it will become the raw material for the other questions. Please remember that. So C option is the answer, because basic groups are more than acidic group. It will take just 1 or 2 seconds for you people to do this question. Question number 8. Which one is wrongly matched? So you have to find out that which one among the following is basically wrongly matched. Let's understand. Okay. My dear friends, you are knowing about pyrimidines and purines. These are nitrogenous bases. And what are these? Thymine, uracil, cytosine, guanine, adenine and thymine. Okay. They are telling us that thymine and uracil are pyrimidines. Uracil and cytosine are pyrimidines. So let's find out first of all purines and pyrimidines. Have a look here. We have our nitrogenous bases. In nitrogenous bases we have purines and pyrimidines, you can say, or pyrimidines, it's your choice. Okay. In purines we will have adenine and guanine. So we will have here adenine and guanine. And you are aware that in pyrimidines we will have cytosine, uracil and thymine. Let's represent it by A, this one as G, C, U and T. My dear friends, you can easily do it now. Okay, we have already done purines and pyrimidines. Okay, so have a look here and tell me the answer. You have to tell me that which one is wrongly matched, which is not the correct match actually. Have a look. Thymine and uracil. Thymine and uracil are pyrimidines. Have a look here. Thymine and uracil are pyrimidines. Correct. This is correct. First one is correct. Okay. Second one, uracil and cytosine are pyrimidines. Look here. Uracil and cytosine are pyrimidines. Correct. Third one, guanine and adenine are purines. Look here. Guanine and adenine are purines. Correct. Last one, adenine and thymine are purines. Adenine is basically a purine, but thymine is basically what? Pyrimidine. So this guy is basically your adenine. It is a purine. And this thymine is your pyrimidine. So this option is wrong. So I will tell that. They are telling us that adenine and thymine are both purines, which is wrong. Okay? Because adenine is purine and thymine is pyrimidine. That means they are not purines. One is purine, one is pyrimidine. That means this is the wrong matching. So when this is the wrong matching, this is our answer. So D is our answer. Which one is wrongly matched? This is correct, 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 and this one is incorrect. So the first one is correct, second one is correct, correct, and this one is wrong. So obviously our answer is the D option. Dear friends, let's talk about the question number 9. Which vitamin is neither soluble in fat nor in water? So let's talk about that vitamin. Before doing this question, let's have an idea first of all. Okay, you have vitamins like DEKA. What is that? DEKA. Vitamins like DEKA, DEKA. What these vitamins are? They are fat soluble. Remember that? Okay. Then you have vitamins with you. Like you can have B group vitamins. Let's start from here. B group vitamins. And C vitamin or vitamin C. Vitamin C. So B group vitamins you can take B1, okay, then B2, B6, B12. Okay, my dear friends, these vitamins are B group vitamins and vitamin C. They are water soluble. Okay, then we have an exceptional case here. Have a look. Let's talk about an exceptional case. Exceptional case is basically vitamin H. Okay, this is an exceptional case. Vitamin H is also known as vitamin B7. Okay, so when you look at the name vitamin B7, you will find out that it is a B group vitamin only. So vitamin B7. Okay, so you can also call it as B group vitamin. You can also call it as biotin. So your vitamin H is basically the vitamin B7. Okay, vitamin B7. It's also known as B group vitamin and also known as biotin. You know that B group vitamins and vitamin C, they are water soluble. But this vitamin H is an exceptional case. Okay, it's known as vitamin B7, B group vitamin or biotin. Okay, what kind of exception is here? Have a look. This vitamin, it is neither soluble in fat nor in water. Please remember that. So this is the vitamin which is neither soluble in fat nor in water. So my dear friends, the answer is vitamin H. And vitamin H is also known as B7 vitamin, and you can also call it as biotin. And A and D, if you look at A and D, have a look here, deca. A is here, D is here, deca, that is fat soluble. So these two are basically fat soluble. And if you look at vitamin C is here. So vitamin C is here, it's water soluble. So it is water soluble. But this guy, biotin, is neither soluble in water nor in fat. So answer is vitamin H. And you know, everybody knows that vitamin A is also known as retinol. So this vitamin A is known as retinol. Vitamin D is known as calciferol, and vitamin C is known as ascorbic acid. These things we already know. Please remember that. Make a note of this. Dear friends, which one among the following is not a polymer? Like nucleic acids, proteins, and then polysaccharides and lipids. My dear friends, we have done nucleic acids, proteins, and polysaccharides, correct? We know that they are all polymers. So our answer will be lipids. Okay? So we can directly go to the lipids, that lipid is not a polymer. Lipid is not a polymer. But let's understand them. Okay? Let's have some information here. Nucleic acids, basically. You can have DNA and RNA as a nucleic acid. Okay? Now you can call it as a biopolymer. Nucleic acid is a biopolymer. Correct? It is made up of nucleotides, and these nucleotides are nothing but, you can call them as monomers. Correct? So our biopolymer nucleic acids, DNA and RNA, okay, it's made up of nucleotides. Correct? And what is nucleotide here? Monomers. Okay. So if it is made up of nucleotides, how many nucleotides should be there? Okay, in a nucleic acid. Okay. So the point here is that in nucleic acids we need to have 13 or more than 13 nucleotides, then it can make, you know what, a polymer. Which polymer? Biopolymer. So it should contain, I will write here N. N stands for number of nucleotides in nucleic acids. Number of nucleotides can be greater or equal to 13. So how many nucleotides should be there? N stands for number of nucleotides. So number of nucleotides in biopolymer, which biopolymer? Nucleic acids, should be either equal to 13 or greater than 13. It can be 1000 also, 2000 also, 10,000 also, does not matter. But the condition is that, basic condition is that it needs to have number of nucleotides, N stands for number of nucleotides, equal to 13 or greater than 13, correct? So it's a biopolymer made up of nucleotides. Everybody is aware about proteins also, okay? Protein is also a biopolymer, a natural polymer, correct? So it is made up of amino acids, okay, through peptide bonds, linked through peptide bonds, linked through peptide bonds, correct? So my dear friends, here the N value, N here stands for number of amino acids. So N value should be here greater than 100, correct? So N here means number of amino acids. Number of amino acids in a protein should be greater than 100. Remember that. There are exceptional cases also. I discussed last time. The exceptional case like insulin is there, okay? That has only 51 amino acids and that is also a protein. But usually the number of amino acids in a particular protein should be greater than 100. Let's talk about polysaccharides. In polysaccharides we can talk about like glycogen, we can talk about like starch, yes. So we can talk about the glycogen, we can talk about the starch, and these are basically our what? These are our polysaccharides. Okay, my dear friends. And even you can take cellulose also. Okay, extra. So you can also call them as biopolymers. They are also biopolymers. What is the N value here? And first of all, I will tell you, they are made up of monosaccharides linked through glycosidic bonds, and remember, here the N value, N here stands for number of monosaccharides, like sugar units, should be greater than 10. So N value is here, number of monosaccharides in polysaccharides should be greater than 10. So when we talk of number of monosaccharides should be greater than 10, they can be 100, 300, 1000, but they should be greater than, you know what, 10. So remember my dear friends, polysaccharides we have glycogen, starch, cellulose. They are biopolymers. They are made up of monosaccharides linked through the glycosidic bonds. And how many monosaccharides should be there? The basic, you know, where from you are starting. The monosaccharides should be more than 10. Then there is a formation of polysaccharides. And this can go beyond like 100, 300, 3000 like that. And in case of proteins, which are also biopolymers, okay, the N value, the number of amino acids should be greater than 100. Exceptions are there like insulin, which has only 51 amino acids. Now if you look at the nucleic acids, you have DNA and RNA, it's a biopolymer. It's made up of nucleotides. So nucleotides are here monomers basically. And here the nucleotides in a particular DNA or RNA, or we can say nucleic acid, should be either equal to 13 or more than 13, like 100, 1000, 5000, 6000, like that. Okay. Now there remains only one, which is lipid, and it's not a polymer. So what is it actually? So I will write here lipids. It is not a polymer. Okay, so this is our answer. Lipids, or we can say lipid, it's not a polymer. Okay. If we say then what are lipids? Lipids are a class of organic compounds that are fatty acids or their derivatives. So look here, a class of organic compounds that are fatty acids or their derivatives or derivatives, you can say, insoluble in water but soluble in organic solvents. Like you have chloroform. Chloroform is an organic solvent, so you can dissolve the lipids into chloroform. So they are just a class of organic compounds, and they can be your fatty acids. So lipids can be your fatty acids or their derivatives, means their molecules or complex molecules with the other substances like glycerol and all. And you know the lipids are insoluble in water, but they are soluble in organic solvents like chloroform. So remember, my dear friends, lipids, if we talk about, it's not a polymer. So I will say that not a polymer. So answer is basically D. So lipids are not the polymers. They are basically either the fatty acids or the derivatives of fatty acids. And lipids are insoluble in water but are soluble in organic solvents like chloroform, alcohol, etc.